Welcome to the 124th video in our series about Unix tools. In this video, we will look at a mysterious 2012 archive again and see if we can get code stored within it to run. In video 123, we worked on fred.rex, and this time we're going to look at fred.sh. Let's do it. So, we already installed the Regina Rex in the previous video, so we don't need that Regina Rex anymore. See, Rex still works. Let's go into Fred stuff. And you can see fred.sh right here. This is the only one we haven't worked on yet. So let's take a look inside, see what we get. Oh, this one has a different original author. But your speaker at the moment is still guilty of working on the code later. So this one was designed to mimic the fred.py. So it should work like fred.py. It probably has the same bugs as fred.py. But you can see it's got a hash bang at the beginning. This is a scripting language. Bash is a scripting language. So we're going to have to work on our permissions here. So we've set the permissions up for a scripting language. Let's run it. Same familiar prompt. H gives us pretty much the same help we always get. So let's try esimple.txt and lists. So far so good. Let's try to delete line 3. That seemed to work. Let's delete the first line. That worked. Delete the last line. That worked. Reload simple.txt. Let's try some ranges. Let's delete the 4-2. That really caused problems with some of the other programs. This one detected that, and it says bogus delete range. Now the message is not pretty. We shouldn't show the space, but at least it gives the right message at the right time, and the buffer is not broken. So this is a bug, but it's what we call a cosmetic bug. Cosmetic bugs are basically, it's not pretty. No technical problem, but it's not pretty. So we'll fix that, but let's keep our testing going. Another one that caused trouble on some of the programs was to give a range that begins and ends on the same line. That seemed to work fine. Let's do a range that starts at the beginning and does not include the end. That should leave us with just one line 5. It does. And when we try to edit a file that does not exist, it said there's no such file. Did it leave one line in the buffer? It did. So this shell version of the editor seems to be the best one we've tested so far. So that's nice. And the range from the beginning worked. Let's delete a range that includes the end. That worked. Let's do the D for the whole range. That worked. Now let's do a range that includes the middle but not the endpoints. And this is 2-4, which is a correct range because the beginning is less than or equal to the end. And that worked. Another one was D with no argument, and it should delete everything. Yes. Oh, I'm totally happy with this. We haven't had any bugs with the delete command and the E command, except for the cosmetic bug about the message having that extra space right here. That was not pretty. But otherwise, everything's looking good. Let's do some add. So right now, there's nothing in the buffer. If we say add to line 3, what's going to happen? And it's smart enough to know, oh, forget about the 3. So this is 1, 2, 3, 4. And then we'll put a dot by itself. Okay, 1, 2, 3, 4. Let's add at 0 to see if we can add before the first line. Yes, it worked. And line 2 is kind of silly. Let's delete that. That seems to work. Let's add after line 5. That seemed to work. I'm pretty happy with that. So it looks like add can add before the list. It can add in the middle of the list. It can. Did we add in the middle? I don't think we did. We added at the end of the list. We added with nothing in the list. Okay, let's add in the middle. So let's add after number 4, which has the word 3. So we'll put 3.5. 3, 3.5, 4, 6. Yeah. So add has no bugs that we can see. We've tested add, we've tested delete, we've tested E, we've tested help, we've tested list, and we've tested quit. So the only bug we need to fix is the cosmetic bug when we did our invalid range where the start was greater than the end, which was something like D4 minus 2. And we get this extra space right here that we don't like. Cosmetic bug. So how do we tackle it? We have to find where this message is in the shell code. And even if you don't know shell code, maybe if we just find that message, we can figure out why we're getting the extra space and we can get rid of it. So we open up fred.sh and we need to search for that string literal. If I turn on line numbers, it's on line 131, and it's nowhere else. It's only here. And you can see that it printed this, and it did 1 to the end. And what we need is some kind of strip command to remove any spaces from the beginning or the end. And do we have one in this code anywhere? We're going to do it the hard way. We're just going to look at all the code and take a look. And you can see this code has the problem where sometimes there are tabs here and sometimes there are spaces, which is why we get this ugly indentation. And if we look, most of the time there are no tabs. They're only tabs on a few places where somebody fixed something. So let's fix the tab problem in the source code first. And we're going to say tab stop. Oh, we need to figure out how much the tab should be. All right. So how can we do that? Here, this is a good one. This then should have the same indent as the LF. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this code is designed with tab stops being 8. So set tab stop equal 8, soft tab stop equal 8, shift width equal 8, expand tab, re-tab. Let's go back to the top, do a quick scan through. Okay, looks good. Save it. Okay, now we can at least maybe understand the indentation. So this is if then elif stuff, get line number, get range, add command. Looks like this is some kind of regular expression stuff. Del command. Help list. Edit. And here's the main. So the code structure has the same spirit as the other implementations. But I haven't seen a strip anywhere. So the next thing to do is probably admit, hey, we're not bash experts. Let's go to the internet and get some help. So you go to the internet, you open up a tab. And then what question do we ask? Well, we say something like bash shell strip. Trim is another word. So let's go with trim white space. Yep, that sounds pretty good. And you see somebody else look for strip white space. So strip and trim come from the names used by different programming languages for the same job, which is to remove leading or trailing spaces. And here it says, bash shell trim string. These are all basically the same thing. So let's try the first hit first. How to trim white space from a bash variable. Okay. And they say xargs will do it. We're looking at the dates here for the latest one. And you can see they're all pretty old. And this is Stack Overflow, which is usually pretty good. So we'll open that in the tab, and then we'll scroll down and see if there's anything better. Okay, this guy is using sed. I don't really want to have to do that. This guy uses tr. So you see there are quite a few different approaches. This one even uses sed, awk, internal path expansion shell feature. Ooh, that I like that. That sounds good. And then we keep reading. Top answer is using awk. We don't really want to do that because we're trying to write in shell, right? If we wanted to write an awk program, we'd write an awk program. So, okay. Python has a function strip that works like PHP trim, and they want that. And then here's something from GitHub, and it's a GitHub gist. Let's try the GitHub gist, see what we've got. Let's define a variable containing leading, trailing, and intermediate white space. Yeah, that's got it all. How do we remove it? And they use the tr command. This one uses the sed command. This is also using the sed command. Okay, we come over here. This one is using the xargs. This one's using sed. When you look at the answers, remember you want to look for a green check mark. And this is really cheating. They call Python. They say Python has the function. Okay, call the Python function. Oh, goodness gracious. This one's calling something called trim. Which uses Perl. And this one's using sed. This one's using sed. Ah, what is this here? Let's see if trim. This is a bash function. It's got while true. I like it. It doesn't call sed or Python or awk or tr or any of that other stuff. So scroll down and see if there's any comment that said it was bad. No comments saying it was bad. So I like this. This looks like a pure bash solution. And they don't have any license information, so I'm just going to grab it. If they posted it, it must be public. Where do we put that thing? Well, we'll put it at the top of the file, like that. And we've got our trim function, borrowed from Stack Overflow. We want the indentation to match the other code. Okay, does that, oh, these needed. Okay, so it looks like I've got the style matching the same as the get line no. And we never had a trim anywhere else, right? That's the only one. So we didn't, redefine a function. So we've got the code, and we need to figure out how to call it. So this guy says, here's a unit test. And they let's see here. .trim.sh. So that must have been this to define the function. And they do all these echoes, then they do an X check. And they say, they're reading from, they do the enum, which will print, echo prints all these strings, and they go through X check. And X check will go through and do this stuff. And they use TR, but the TR is to compare, right? They do it with TR, and then they do it with their function, and they print the results so you can compare them. But it looks like this is how you call it. Right? Right there. That's how we call the trim function. So even if we don't completely understand it, the test ln is clearly some variable, right? That they read in. Now they redefined it here, which I'm not sure what that does, but we're not gonna worry too much about it. We're gonna say that's how we do the function call. And then we're gonna come in here and say, where did I need the function call? Well, it was something about bogus. Bogus range detected. I think that was it. Bogus delete range. Okay. Bogus delete range detect. This is it. And so we want this guy right here, we want that to be trimmed. And the trim thing took a variable. And all we have is the $1. So we saw you do local like this. So local bad range equals that stuff. And then, oh, life on Windows is so hard. I mean, you mark it, but it's not marked until you press some stupid keystroke, and then we'll try it again. And I'm sure the Windows people will say, the stupid is you, John. Bad range. Okay, and I like the style like this a little more. And so that should do it. And we'll comment, we'll keep the original because I don't want to break it. Okay, and then this should be bad range if we understand what's going on, because we put the $1 into bad range, we ran trim on the bad range and put it back into bad range, and now when we print the message we should be getting the trimmed bad range. And we didn't change anything else, so enough talk, right? Let's see some action. So we put in that same bad command. Oh, look at that. Look, would you look at that, baby. So it's fixed. We fixed that bug. I'm very happy about that. Using code from Stack Overflow that we hunted down. Even though we didn't, systematically train on Bash or anything, we were able, with a little bit of experimentation and some basic common logic, we figured out how to fix that bug. And since it's not some critical math calculation or anything, I think we can just say we ran the test, it looks good, it's good. If it was about money or something, you'd want to do more testing. So bogus delete range, and we delete the comment one now. This is good enough. And you might think, well, I've got this bad range and I've got this bad range, can I do it like that so I don't have to have this one? We're trying to we got it to work, and now we're trying to see, can we reduce the line count? Can we make it a little bit simpler? Still okay. So yes, we can delete that. Now the next question is, do we really have to have the bad range variable, or can we just put this stuff on the end of the next line? I've commented out this one. Oh, yep, and I can comment out this one now. And can we just call trim on that $1 and everything will work? That'd be nice. That would be just change one line and it all worked. But maybe it's not that simple. Okay. I'm very happy about that. Because it really is as easy as calling trim in some other language. The function called syntax is a little weird. You wrap it here, and you have to have that thing. And because we're doing a string, we have to put the outside quotes there and there. But inside, you call trim, and instead of saying trim left parentheses argument right parentheses, you use a space. Okay, but that's the first argument, and it's what we were using before. And so all we really had to do was add this on the left and add this on the right, and problem solved using this trim code from Stack Overflow. Even though we don't understand exactly what it's doing, and if you want to be a bash programmer and be serious, of course you would need to go get a bash reference and go learn what this is doing. Okay? Learn what this is doing and study it. But that's not our goal today. Our goal today this is not a bash training video. This is a video about getting some old source code to work without being an expert in the language. And we did it. We did it with Rex. We did it with C. C was tough. But getting the Python fixed, that was easy. The Rex, which we'd never seen before, that was easy. And it turns out this bash wasn't too bad. All with a little bit of online searching with the right questions and some logic. And most of the time, for a simple problem like this, many people are going to want trim. When it's not built into the language in an easy function call, if you search, you'll find somebody else solved this problem already. And you saw we had so many bad false start answers with just these, calling awk. It's like using a nuclear missile to kill a mosquito. That's way more power than we need. And it's going to be slow because it has to start up another process and load the arguments into the process. And then it has to, awk has to sort of compile that internally and run it. We don't want a solution like that. We want a solution that's, if we're doing bash, that's written in bash, if we can. So, wonderful. We did it. We didn't use TR. We didn't use sed. We didn't use awk. We didn't do any of that silly stuff. We have a pure bash solution. And it sort of looks like all the other code. If you wanted to really clean it up so that it looks exactly like Mr. Ham's other code or the other student's other code. We could add a few of those things to fix the style a little. We already fixed the spacing indentation, and this will fix the style. What if they sent in an empty string? Okay, we don't want to crash on that. Some little details. After you do that, you got to make sure and test that, what looked like a good idea didn't break anything. Yes, it still works. So now the style matches the style of all the other stuff in this program, and we accomplished our goal, and we did it all in half an hour. And that you could have done it more quickly if you weren't talking and doing those. If I wasn't trying to explain it, if we're just trying to do it. This is a 10-minute job. 10-minute job. to take completely alien code from, at this point, more than 12 years ago and fix it. So, did the program get larger or small? It's a little bit longer, but not much. It's still shorter than the C program. And we learned that the shell program was the least buggy. You know, it only had one bug that we found that was cosmetic. The Python and the Rex were about the same level of bugginess, and C was worse. And that's sort of to be expected, although I was surprised that the shell code was higher quality than this. But you saw, if you read the comments in fred.sh, it says mimic fred.py, mimic, copy, be just like. So this one was written after fred.py, and maybe when they were testing fred.py, they saw the bugs and fixed them in here, but they didn't fix fred.py. Whatever it is, we've got all this code cleaned up, and I've shown you the point of this short 4-video sequence is to show you debugging in 4 different languages, but keeping the program that it's implemented exactly the same, like a Rosetta Stone. They all implement the same commands for the same sort of text editor. And they have to do it different ways because the languages have different features. And the reason why Fred was the buggiest was because Fred didn't have any kind of natural list support or array support or anything like that that we could use. And it uses pointers. And whoever worked on it originally didn't test enough. If you take all the time from all 4 videos, including, having to build our own Rex, it's still only a couple of hours. And that's assuming you're 100% newbie and you don't know anything. After you have some skill, which you should have after this video series, you would be able to do this in a lot less time. So I hope that you enjoyed the opportunity to see the same program implemented in 4 very different languages and debugging them all. Take that debugging logic, that debugging skill, and that no fear attitude. Yeah, it's a language I don't know. So what? I've got, I pop up my advertising machine. This one was the good one. So with a little bit of Google or whatever your favorite search engine is, in today's world, there's no excuse not to be able to fix those programs. Even if you have to go out and build your own Rex, you can do it. It's not that hard. And it can be fun. But the only way it can be fun is if you take the right attitude and you talk about what you can do instead of doing what I've seen some students do. They go in, they panic, they say, I've never seen that, I don't have any training on that, I don't have a book on that, I don't have a video on that. Well, now you do. Okay? But their default setting is give up, it's too hard. Your default setting should be I can do a lot, and I don't know if I can do this one or not until I try. Let's try. And there's always the internet to help. So if you take a positive attitude and you enjoy solving puzzle problems, programming is for you, and the Unix environment is a great place to do it. I want to end this video on this happy note and say that even if you didn't have fun, I had fun debugging these. And I hope you come back next time. We've already finished all 4 threads, so you know it'll be something different. Thank you for listening.